Here's a horrible one. X plus y plus z equals, z equals 0. X plus 2y minus 3z equals 5. And 3x plus 4y plus 2z is equal to -1. Now, where before we were talking about two lines running into each other at a common point, these are not lines. These are the board moved in different angles, angled this way and angled that way and every which way you can imagine. They're planes. So each one of these is a plane. And the only time you get a single point of commonality between three planes running into each other is where? Let's go over to this corner. This point is common to two walls. The wall on your right and the wall to your front. So where is it that the wall to the floor is also common to them?
To your right? At the bottom.
At the bottom, way down there in the very far corner of the room, or at the very, very top. Well, to the floor it would have to be the bottom. So what we're looking for is where three planes come together at a single point, which is just, you can't even imagine it in your heads except with the walls in front of you. So algebraically is the only way to solve this. So what technique do you think we should use? Substitution? Elimination. Choose a variable to get rid of. But once you choose it, you have to get rid of it twice. So you get to choose. Do I want to get rid of it in the top two equations and the bottom two equations? Or do I want to get rid of it in the top two equations and the first and the last?
The last one didn't.
So you get to choose which one you do. I highly suggest you do the top two and the first and the last. Why? Look at the z's. 1z, 3z, 2z. Which one's easier to change into 3 and 2? The 1. Because 1 times anything, I can make it anything. It becomes what's called scalable. So I'm going to choose, let's call this equation A, call this one B, let's call this one C.
Are you right-handed?
Oh, with the green and the blue I have no problem with. It's the other marker that doesn't work out very well. All right, so I'm going to take the first equation, A, and I want to add it together with the second equation, B, so that the z's go away. Eliminate z. That's my goal. Get rid of the z's. So what number do I multiply A by and B by?
Positive 3.
Positive 3 for A. That'll make it 3z. Do I want to change B? No. So 3 times A, 1 times B is my setup. So I'm only concentrating on the first two equations, A and B. I'm ignoring C completely. So if I add those together in this fashion, 3 times A is going to be 3x plus 3y minus plus 3z is equal to 0. Because 3 times 0 is, well, 0. All right, 1 times b, I'm just going to copy b down. So it's x plus 2y minus 3z is equal to 5. And I'm going to take those two equations and add them together. Now, if I add two lines together and they share a common intersection point with the original two, if I add two planes together, guess what happens? You get their common intersection. Now, the intersection of planes is a line. So you get their common line. All right. So get rid of the z's and you're left with 4x plus 5y equals 5, which is the equation of a line in the xy plane. A normal equation of a line that we're used to. All right, that's one of them. Let's do the other one. We chose A and C because it's easier to change a 1z into anything I want it to. Oh, it just made a bunch of stray marks. Get rid of those. All right. So
You know it needed. You heard it.
I can hear it. It's a very low pitch. All right, so if I'm going to get rid of the first and the last, it's going to be a plus the c in some format. I'm leaving a space in front of the a in front of the c. What do I have to multiply by a by to get rid of the cz?
-2.
Equation c is the letter z. -2, right? So -2 times a, and what times c? 1. So that's my setup. So -2 times a, that would give me -2x minus 2y minus 2z is equal to, well, boringly, 0. And then I just copy c down. 3x plus 4y plus 2z is equal to -1. Take these two equations, add them together. I should really put that in a circle.
-6
What?
x.
Adding them, not multiplying.
Sorry.
X
Plus 2
plus 2y
equals
equals -1. Now, x plus 2y equals -1 is also a line in the xy plane. So what can we find?
x and y.
I have 4x plus 5y equals 5 in the xy plane. I have x plus 2y minus 1 in the xy plane. They are two lines in the xy plane.
You find some.
I can find where they
Intersect.
intersect. I mean, they're going to have a point. They're not parallel, that's for sure. Just by looking at them, this is 4, 5, this is 1, 2, nothing in common. So how do I find the intersection of this line and this line?
Some equal to it?
Well, you could solve for one variable and shove it into substitution, or you could do elimination again, either one. Which one do you think will work quicker?
Elimination.
Substitution.
Oh.
Why would substitution? Why would substitution work better here? Not because of the first equation.
Because the second one.
The second one has just a plain old x. So x equals -2y minus 1. And then I can take that x and substitute it in the top one. So sometimes substitution is quicker than elimination. Sometimes. Only if the variable is
I don't
so.
understand elimination.
You understand elimination?
I don't.
We just did it.
I know. I'm trying to like,
Oh, and I just probably made straight marks all over the place. I'm all the way over here.
but like, how do you find a negative? Like -2 and 1.
Oh, here?
Yeah.
I'm trying to get rid of the z, and this is a 1z in the top and a 2z in the bottom. So I want them to have the same coefficient, opposite signs. So what can I multiply z by to make it the opposite of 2z? -2. So I go through and multiply the entire top one by -2.
It's just a problem with finding them.
Yeah, it's just, if you think about it, it's a common denominator.
Okay.
If you have a 5 and a 7, you multiply by 7, 5.
Okay.
If you have a 4 and a 6, you multiply by a 2 and a 3.
Oh yeah.
Because 2 times 6 is 12, and 4 times 3 is 12. So it's common denominator type thinking. What time is it? No, looks like you're packing up or something.
I'll tell her this.
We have plenty of time. Okay, so I'm going to take these two equations and do either a system or a substitution. Do substitution. So if I solve for x, you're going to get x is equal to -2y minus 1. And I want to shove that into in. So that's going to become 4 times something plus 5y is equal to 5. And by the way, this is one problem. And we've been on it quite a long time. That's okay. So what goes inside the parentheses here?
Hold on, cause we
-2y minus 1.
So inside the parentheses goes -2y minus 1.
I never leave enough space.
Oh, in your parentheses?
Yeah.
Make them really big. So this becomes -8y minus 4 plus 5y is equal to 5. Then what? I did that right.
So, yes.
Yeah. So -8y plus 5y is -3y. If I add 4 to the other side, it becomes 9.
-3.
Y equals -3. I would hate for these to turn out to be fractions.
It's not.
It's not, thank God. If it turns out to be a fraction, I'm sorry. But mine shouldn't. So, if we plug this back in, I'd go one level up. And generally what happens is you keep going a level up to get all your answers. So if I plug in y equals -3 into that, you get x is equal to
5.
-2 times -3 minus 1,
5.
which is 6 minus 1, which is 5. So now you have y equals -3, x equals 5. Now what? I highly suggest you go back to the very beginning, the easiest equation, the A one, and plug in both your solutions, the 3 and the -3 and the +5. So x is equal to 5, y is equal to -3 plus z, and this has to equal 0.
It's -8. No, never.
Try -2. So z equals -2. So the coordinate where all three of these planes run into each other is x equals
-2.
No.
I mean, 5.
5, y equals
-3.
-3, z equals,
-2.
and that's where these three planes run into each other at that coordinate.
Right.
That's weird.
Isn't that cool?
I want to see what it looks like.
Did I bring my computer? I can grab it for you later after I'm done. Well, I can grab it now. I have this cool little program
Sweet.
called GeoGebra. You can download it, it's free.
Called what?
GeoGebra. It does geometry and algebra. So they call it GeoGebra. 3D graphics.
Why you not buying
Ooh, I gotta move it the other way so I can see what the equations are. So this is x plus y. Alright, here we go, ready? If you want to come up here and see. I'm not gonna put it up on the thing. These are the three planes running into each other. And there's their point of intersection, that A.
Oh, that's weird.
Isn't that cool? So it's where the only point that those three planes have in common is that point that we just found. Much easier to do algebraically than actually seeing the picture and going, trying to figure out where it crosses. It's really hard to represent 3 dimensions in 2 dimensions. I mean, it's really, really hard to draw a 3-dimensional object on a piece of paper. Try it sometime. But that's what it looks like, and that's the whole process. Yeah, that became part of the video. They don't get much harder. I'll even actually do an easier one that looks harder.
It's really easy.
It's hard trying to figure out which equation.
The process is long.
Yes.
The technique is easy. All you're trying to do is get rid of variables, get rid of variables, get rid of variables. But the process is you have to get rid of the same variable, then come up with more, and get rid of another variable, and finally get to a number, and then you have to backtrack all the way to the beginning to get all of your solutions. So sometimes it becomes quite messy. Ooh, let's try this one. 2x plus 3y plus, that's a plus, I don't know what happened to that. I was thinking of the 7 next. 7z is equal to 13. 3x plus 2y minus 5z is equal to -22. If I screw one of these numbers up, so you gotta be really careful, your eye can't wander on these problems. You screw one number up, and you're all of a sudden talking fractions. And once you start getting fractions, it gets really horrible. So I'm trying to be really careful when I copy this down. Number 10. 5x. This is number 10 out of the book, in case you want to make double check I'm doing this right. Plus 7y minus 3z is equal to -28. 3 planes, and we're looking for their point of intersection. Okay. I'm going to start off calling the top one A, middle one B, and the last one C. Equation A, B, and C. Where Z was really nice and easy to get rid of last time, and this one, it really don't matter which one you pick. Just pick one. Most people get rid of Z all the time. But if you want, I would highly suggest you get rid of X or Y. It looks easier than Z itself. So pick one, X or Y.
X.
Alright. So get rid, that's not how you spell rid of X. So if we're going to get rid of x, are we going to do the top two, bottom two,
Top two.
or we're going to do the top two and outside ones?
Top two.
Top two, bottom two? Remember, you have to do it twice. So you have a choice. You do it to A and B and C, or you do it to A and B and A and C.
I'm gonna do A and B, B and C.
A, B, B, C? Okay. So if we do A, B, B, C, we'll start off with A, B. Now I'm leaving spaces in front so I can choose the numbers to multiply by. So if I'm getting rid of x in the top two equations, A and B, what do I multiply the top one by? What do I multiply the bottom one by?
3, -2.
3 and -2. That'll do it because it'll be 3 times 2x, which will give you 6x, and -2 times 3x, which will give you -6x. And when you add them together, they go
Okay.
poof. All right, so 3 times a,
6x
6x
plus 9y
plus 9y,
plus 21
21z is equal to
30.
39. Okay. And then be careful with negatives. -2 times all of b. So -2 times 3x is -6x. -2 times 2y is -4y. -2 times -5z is +10z is equal to -2 times -22,
44.
+44. If you screw up a sign, everything's messed up. So you gotta be really cautious through all these processes. Take these two and add them up and see what happens.
5y
5y plus 31.
So you're gonna get 5y
plus 31z
plus 31z
equals 83.
equals 83. Ugh. It's horrible. Oh well, life goes on. Next setup. We're going to do the last two, right? B and C. So we're going to choose B, and we're going to add it to something times C. Now remember, we've got to keep getting rid of x. Don't switch variables. You have to focus on one variable through the entire process until you get to linear equations. All right, so what times B plus C to get rid of the x's?
-5.
So you want to multiply the top one by -5 and the bottom one by +3. That's fine. You could also have done +5 and -3. That's perfectly fine also. Either way works.
So when you multiply it, either or it has to be a positive or negative. It doesn't matter which one.
Well, it doesn't matter because as long as one's opposite the other, when you add them together, you get 0. That's the rule.
So it would be -15.
-15x
Minus 10y
minus 10y
plus 25 z
plus 25z is equal to
positive 110.
+110. -5 times -22. Ooh, the numbers are getting big. All right, and then 3 times the bottom one. Don't get confused with the middle one, the bottom one.
Oh, I thought you said negative.
So it's +3 times everything here. So 3 times 5,
15
which is what we want because we want those x's to go away. +3 times 7, +3 times -3 is equal to, I have no idea, what's 3 times 28? -84. And then take these two equations, add them up, see what happens.
11y, right?
Mm-hmm.
Get 11y
Minus
plus
Like 14.
15, 16,
Wait,
16.
16
Yeah.
z is equal to 26.
Yeah.
26. Wow, isn't that awesome?
It's big.
Now I have to take those two, the green and the blue,
Put them together?
and somehow getting them together. So do we want to do substitution with that mess?
Elimination.
Elimination. So I'm going to take this and call this, well that was A, B, C. Let's call this one D. Let's call this one E.
Not P. You said D.
D and E. So I can talk about it. What variable do you want to get rid of?
The Y.
Y or Z?
The Z.
The
Y.
The Y.
Oh, okay.
The numbers are smaller for the Y.
Okay.
Z is 31 and 16. I mean, ugh. So the Y. So if I'm going to get rid of the Y, I'm going to take D and I'm going to add on an E. What times D and what times E?
-11.
Negative 11 on the D and positive 5 on the E. That'll guarantee get rid of the Y's or the Z's.
The Y.
The Y's. Guarantee get rid of the Y's. Told you this stuff isn't too bad. Alright, so negative 11 times 5Y.
Negative
55Y. Ugh. Negative 11 times 31.
Negative 341.
Negative 341Z. And then finally, negative 11 times 83.
What in the world?
913.
How much?
913.
Ugh.
This is just
Positive or negative?
Negative.
Negative.
Oh yeah.
Yeah, because this is a positive times a negative. Whew. Now, 5 times E. Well, 5 times 11 is 55Y. 5 times 16 is 80
Plus 80.
Z. Yeah, plus 80. And then 5 times 26 is 130. So this is 130. And take these two and add them all up. Just because the numbers are getting big does not mean you're doing it wrong. This is expected.
I know I would have stopped. I thought I was doing wrong.
So the Y's are gone. The Z becomes negative
261.
261Z is equal to negative 783, and I hope to God that 261 goes into 783. So what's 783 divided by 261?
3.
Isn't that cool? All those big numbers,
All that for one of them.
and you get
3.
3. But that's good, because it's not a fraction. If it was a fraction, I'd really worry. If it was a fraction, I would actually think I did something wrong, because these usually are nice answers when they have a system of 3 equations. Now, since Z is equal to 3, how do I find something else?
Why?
Plug it back, backtrack it. So I need to backtrack it, so I'm going to backtrack it to that equation, or D, it doesn't matter, it doesn't matter.
You take it back with D and E and don't go to your main?
Yeah, you kind of go backwards through your whole problem. So here you have Z by itself, here you have an equation in Y and Z, so you can find Y. Once you have Y and Z, you go back to the very beginning and then you can find X. So find one of them and then go backwards. Do you want to put it in D or E?
D.
D? Alright, we'll go skip that one over and go right to him. So this becomes 5Y plus 31 times Z, but Z is 3, is equal to 83.
So 31 times 3 is 93.
And if I subtract 93 across, that gives me negative 10. So Y equals negative 2. So there's 2 of my answers.
Wait a minute.
Then you plug both.
Wait a minute. This is 93. If I subtract 93 across, I get negative 10. 5 goes
You
into
confused me
negative
when you said subtract it across. I'm like,
subtract it across. Now go back to the very beginning. A, B, or C? A. So that becomes 2x plus 3y, but y is negative 2, plus 7z, but z is equal to 3, and it's supposed to equal 13.
so 2x plus negative 6, or what, 2x
Yeah.
minus 6.
2x minus 6 plus 21 equals 13.
And negative
2x plus 15
2x plus 15
equals 13. X
equals
equals negative
13. And x equals negative 1. Phew. It took up the entire board to find that the solution to that system is x equals negative 1. Always has to go first.
Negative 2.
Y is second, negative 2. And z is third with 3.
Yeah, permanent markers.
Imagine if it was, that'd be horrible. Isn't that cool? I always thought this was kind of neat. The process is just repetitive. It's very repetitive. Get rid of, get rid of, get rid of.
What's that the last